This is the video notes for 11.2, x on both sides, make one disappear. The first two examples we're going to do are actually just to prove that it doesn't matter which side or which x you make disappear. You'll notice that example 1 and 2 are both the exact same questions, so supposedly they should come out the same way. So let's start with example 1. Every time we see an equal sign, we're going to draw the wall. And again, we have x on both sides, so we're going to make one disappear. In this case, I'm going to make the negative 12 disappear by adding 12x to both sides. So I end up with 17x on one side, minus 7 comes down, and the 12 comes down. And then we go to our famous junk and divide. So the junk, minus 7, so we add 7 to both sides. We get a 19 and a 17x. That was junk. And of course our last step is divide. So our final answer is 19 over 17. Again, you guys can put it in a calculator and get a decimal, but that's basically what we're looking for. Let's go to example 2. Example 2 is the same exact question, but this time we're going to get rid of the other side. So again, we're going to draw the wall. And this time, instead of getting rid of the 12x, we're going to get rid of the 5x. So we subtract 5x from both sides, making that disappear. And we get 12 minus 17x. Now, the x is on the right side of the wall, so we're going to get rid of the junk, which is the 12. We get negative 19 equals negative 17x. And when you look at the other side of the other example, you'll notice that the signs are exactly the opposite, but it ends up working out. As we divide by negative 17, and again, we could put it in our calculator, simplify it, or turn them into decimals, but it ends up being positive 19 over 17, just like the other one. So, x on both sides, make one disappear, and it doesn't matter which one. Let's take a look at some of the curveballs in this. Example 3. Example 3 really isn't a curveball, it's really just ugly. In other words, there's fractions all over the place. So I'm going to draw the wall and go through this. So again, we have x on both sides. The rule is make one disappear. I typically make my right side disappear because I just like my x's on the left at the end. But we know ultimately it doesn't matter. So 2/3 x, make it disappear. And again, you're either great with fractions or you have a good calculator. In either case, it's ugly, but it can be done. So when you pop this into your calculator, you end up with 13 over 3x. Again, minus 4/5 comes down. Those disappeared, and the only thing left is the minus 18. And now we go back to our famous junk and divide. And again, this is just ugly because there's a lot of fractions. Our junk is the negative 4/5, so we do plus 4/5 to both sides. I absolutely use my calculator on that. So my next line is 13 over 3x equals, and it ends up being negative 86 over 5. Last but not least, divide. Again, it's ugly, but we divide by the number in front of x. And again, I'm going to press pause and click this in my calculator. Thank goodness for calculators. The answer ends up being x equals negative 258 over 65. It's ugly, but it works. Next, let's go to example 4. This one actually ends up being very easy. Again, we have x's on both sides, so we draw the wall and make one disappear. Minus 2x from both sides. And end up with 3x equals 19. And now I go to my junk and divide. Now the great thing about this problem is there is no junk. It's empty, so I go straight to divide. And again, I get my final answer. You can turn this into a decimal with your calculator or leave it as 19 over 3. Example 5. Now for people like me who always go to the left and they make the one on the right disappear, this ends up being a strange one. Again, we draw the wall. There's x's on both sides, so we make one disappear. Again, I always make the right disappear, so watch what happens. Minus 3x, minus 3x. Now, I end up with negative 8x plus 18 equals nothing. And this is where people get in trouble. Remember, nothing in math means 0. So then you have to go through the junk and divide steps. Minus 18 for both sides. And standard divide. And again, if you punch this in your calculator, or if you're good with reducing, you get 9 over 4 or 2.25. Now we're going to take a look at example 6, which is the exact same problem, but this is for people who look at it and decide they're going to make the other x disappear. Again, x on both sides, make one disappear. This time, I'm actually going to make the negative 5x disappear. Add 5x to both sides. And I get 18 equals 8x. Now this time, the x is on this side. There is no junk, so I go straight to divide. So by thinking ahead, we actually saved one step. Not that big of a deal, but for those of you who like to save steps, this is it. The answer ends up being, of course, 9 over 4 or 2.25. You're now ready to solve any problem with x on both sides.